I just introduced this just as to show this is at the county airport. We removed 4 separate tank systems. This is one of them. Bedding and backfill in tanks, this is pea gravel. Pea gravel is a little bit different. It's a bag of marbles. And so dealing with pea gravel is a bit different than solid soil, just from the standpoint of how it handles, the safety requirements. You don't want to get in the hole, of course, ever. Pea gravel is just kind of a big cascading, trying to get to angle repose type of backfill. This site is actually very interesting. This is a old railroad tank. It's an at grade, actually undergrade. The top of it is a 55-foot long concrete tank. It was a railroad tank. It held bunker C fuel oil. We tore the top of it off. These guys are trying to get it clean, so we're going through a process of cleaning it. We have our pumper here. As far as getting in this hole, really no issue with OSHA on this as far as I'm concerned, because it's a very burly concrete structure. So even though it's greater than 5 feet by a skosh, I really don't have a problem with my subcontractor getting in here. But basically, we had to get in this thing and wash it to break it and get it gone. I want to talk a minute just about cleaning these tanks. Again, I know that there's many methods out there: dry ice, haz waste versus non-haz, pumping, cleaning. My experience in my work doing this is steam cleaning and pumping is a very, very good way to clean a tank. My preference is to clean a tank to non-hazardous, inert conditions on site. If a CUPA will allow me to do that, I found that I can do that. I can be effective at doing that, and I could demonstrate through metering and monitoring that that's the case, and I can document that and take it away at a much cheaper cost to do it. Dry ice, though, is something that we still use. Again, dry ice I find to be problematic when you are talking about tanks that are essentially rotten with tons of holes in it. Dry ice doesn't stay, obviously, in that vessel. I looked at some of my local bulletins recently from my CUPA agencies, and you know, they're all about dry ice and closing a tank and leaving a 1/4-inch porthole, and I'm all about that if I can do it, but oftentimes you just cannot do that. My experience is, again, that you could get these tanks clean. I included Reg 8 Rule 40 in here, which is a Bay Area Air Quality Management District. Sonoma County actually breaks between 2 air districts. Your air district, by the way, can have requirements out here for fugitive emissions control, washing, venting, stockpile management. Reg 8 Rule 40 has been around for 15 years, and it's a standard out there for all of those things. And I wanted to talk a minute about the appropriateness of some of our meters. Gas tech out there is kind of the standard. It's almost like a Q-tip type thing that, you know, a gas tech. Well, gas techs and an LEL meter, a combustible gas meter, is great. It's a safe meter. I, by the way, would recommend as CUPA agencies, when you come on site, if somebody's going to use a meter, verify first thing that thing is calibrated. There's way too many times I've had somebody with an uncalibrated meter, and that meter is only as good as its last calibration. If you're going to base life, safety, and health on a meter, it better be a darn good meter that's working. Type and applicability. An LEL or combustible gas meter is perfect for a tank full, or to monitor based on an LEL measurement, lower explosive limit. And there's criteria out there in our CUPA regs and bulletins of what we're trying to strive for as a level to then remove this tank safely. I would tell you, though, applicability that a LEL or a combustible gas meter is really not something that we use. We use a photoionization detector, a PID. It's basically a PID is a measurement of volatile organic compounds. It measures in parts per million by volume. It's kind of a catch-all in that it measures all volatiles, so it's not trying to then distinguish between benzene and toluene or any of those. But nonetheless, it's a very effective tool as a remediation guide. We use it because the NIOSH guide oftentimes has ppmv levels for certain contaminants, so we use a total contaminant load as a measurement of that. So just to kind of shout out about that. This is back, I actually just included this. This is trying to get our tank clean. This is the railroad tank. Bunker C fuel oil with a whole lot of sludge in it. Very difficult tank to clean and inert. And again, here's my guys before and after. Very good job. This is back to the fire station. One thing I wanted to include in this slide is oftentimes the newer generation of tanks have dead men on them, and this thing's bolted down with cables and dead men. So oftentimes your inertion and removal process includes the removal of dead men and other attendant structures, piping and everything else that goes with it. The airport, again, you could see in this picture, these tanks are clean. They've been certified clean. We've got a pretty good sized hole. That's not to allow access in it for somebody to get in that tank because that's a confined space. It's really just to allow us to get in and clean it really well. On the tank to your left, by the way, the big cone coming out is a Venturi air blower that if you hook up air to that thing, it by a Venturi effect moves air, and it could be a very effective way to vent a tank. This is actually a gas station, a big gas station. So these tanks actually went out as HAZ. It was a requirement of the CUPA agency to take them out as HAZ. So we cleaned them. You could see that they're buttoned up. They have all the vent holes that are buttoned up and sealed. They got dry ice in them, and these things went out as hazardous waste under manifest. This is a little tank I pulled last year. You could see a guy steam cleaning it, just trying to get it out. It was under a slab of a building. This tank is no problem to clean this little steel tank and use just a hot washer with it with a pumper. No problem knocking that thing down to acceptable levels. I included this tank because it's interesting. Not all tanks are known. This was a pretty good sized construction site over in Napa. This tank, believe it or not, was a waste oil tank that the gentleman that owned the property way back when reportedly went and got waste oil to control dust on his storage yard. So he went to town as often as he could and picked up waste oil from everybody and threw it in this tank. And then he spread it all over his site to control dust. And these guys go in there with a grader, and they got a big earth mover, and they hooked the top of this thing and ripped that hole in it. And they called me and said, David, my bat phone rang. David, you know what? We have a problem here. We have oil coming out of the ground. Well, it didn't take very long to figure out why. I bring this in because not all tanks are known. Not all tanks are convenient to get to. Sometimes you find them in surprising ways. This is a gentleman that's a pumper guy just starting to clean out product. This tank was chock full of product. It was a 5,000-gallon tank. So we got 5,000 gallons of waste oil to deal with. This is some bringing in dry ice. Dry ice has its own, just because it's cryogenic nature, has issues. It's very cold. As far as safety goes, CO2 is itself is an asphyxiant. It's not a poison or anything like that, but it is an asphyxiant. You need to be aware of that in using dry ice. There is usually, in my experience, CUPA rigs or CUPA bulletins have a prescriptive amount of dry ice, pounds per gallon a tank or pounds per size a tank for dry ice if that's the way you're going to go. Okay, so assuming now we have a tank clean. We've got it loosened. We've got that backfill and bedding material out of it. The dead men are out. We've pulled the piping off of it. We've washed that. We're getting ready for the inspector to come. So what are we talking about? We're talking about lifting this tank out of the ground, going through an inspection process. What does the tank look like? We typically bring it above grade, get it in a safe area, roll it on its side because everybody wants to see, has it got holes in it? What kind of condition is it in? You document then the condition of this tank. You document the safe condition of the tank, that it's an inert tank. You document the condition that it comes out of the ground. And then you've got start to go, that's really your condition assessment. Also, because these tanks are going down the road typically on the back of a semi-truck, you want to make sure you remove scale and soil that's tagged onto this tank. The last thing I want to do is send a tank down the road and have pieces of dirt or scale flying off of it into the fast lane. Also, when you bring it above grade, you want to confirm again that you have inert conditions. And then it's really a simple process, load it on the truck and secure it down. I have found several of the CUPA agencies then require you to label it. We have a stencil, basically, that we label it. There's one agency in particular that wants you to label it that says, this tank formerly contained hazardous materials, not for drinking water. And so we do that. We do it in spray paint. And then, by the way, we plan for contingencies. So here's a gas station, a big 10,000 gallon. It's just going out. This tank's going out as HAZ. It's all clean. You can see on the very bottom of it in the end towards us that it's got some dry ice. You can see the dry ice, by the way, will freeze things to the tank. It'll freeze dirt to it. It'll freeze anything with moisture because it's so darn cold. Here's its companion coming out of the ground. Again, this is a pretty heavy tank. I believe this is a 6,000 gallon tank. In the background is our CUPA inspector talking to one of our guys, just kind of watching what's going on. You could see, again, this site's got full control. It's a big site, big dig, but that's okay. These tanks are, again, out at the county airport. I'll show you another picture of this. These tanks actually were cleaned to inert levels. We smashed them up and took them away as garbage. So just simply getting them out of the hole. Now, back to my bank. These tanks do not come out of the ground easily. These things have been there for a long time, and you could see that they're in really bad condition. So getting these tanks out of here was a real ordeal. This is Saturday afternoon, by the way, and we're trying to get these big white whales out of the ground in one piece. Really, really tough. Just tried to get everything to get these things out of the ground. These had actually, and you could see some of the mud, I think, that got in there when it got kind of scraped against the side. But this thing came out of the ground, and its brother, its companion, broke as we got it out of the ground. You could see on the ground that there's a fair amount of product in this tank that was a problem. Plan for the contingencies, right? So I conferred with our local fire CUPA guy, and I said, Doug, I think what we ought to do is we ought to take this tank and let it break in half, get that material out of it, and get this material and throw it on the soil stockpile so I could contain it, because I'm going to go ahead and get this stuff out of here as has anyway. Let's control this stuff. Let's be smart about it. So plan for your contingencies. We never wanted to take this tank out and break it, but that was the reality of it. We had to kind of go to plan B and C here as we went. By the way, in the background, we have a regional board person. We've got some really interested people. This was a pretty high-profile site, so that's what we had to do with this tank in particular. We did get it on the truck. We got it pretty clean enough to get down the road and get it away in a safe manner. And by the way, I'll bring up the fact, and I pose it as a question to CUPA agencies, whether you allow a tank to be taken out as scrap metal or do you want it to go out as haz waste. My preference is, by the way, is to do it no matter what, do it in a safe manner. I would tell you that there's a tremendous cost to taking out a tank as a haz waste tank. You're talking, in my experience, $2,000 to $3,000 per tank. They then haul it down the road to a facility, they wash it, they then go through the process that I think essentially we, done well, could be done on site. I include a unidoc here because we, under the contractors laws, we use our hazardous substance removal contractor to certify this tank as clean with the conference of the CUPA agency. So I use this document. We document the conditions of this tank. We get signature from attending people. And basically, it's a very nice way to do it, and it becomes part of the site documentation. So again, scrap metal or haz waste, the decision is yours as regulators. But I would tell you, I think good choices can be made with planning to realize what you're really trying to do. This one went out just as garbage. Yes, it was a big tank. It was a 10,000 gallon, I believe, or maybe not, something like that, fiberglass tank. But we got this tank clean enough where it's basically an inert waste at this point. So we had 4 different tank systems like this. We went through them all. We at the ends took them and smashed them all, and in one load on an 18-yard end dump high side, and took them to Redwood Landfill, a Class 3 dump, at a very minimal cost, in a safe manner, by the way. Okay, so we got the tank out of the ground. We all inspected it, we documented that, and in fact, it's going down the road, it's bye-bye. So it's time to go and do some soil sampling, and I'll just go through this because as a consultant, we're really interested whether this tank is leaked, and it starts to become then the next chapter in the story of what this site is. Of course, you want to do representative sampling. There's a bunch of guidance out there about how frequent you sample, what are you sampling for, what's your analytical and regulatory requirements. Going and doing that, of course, you have a myriad of tools. In my experience, some of the jurisdictional agencies, and this is from the regional board level, require what's called an encore sampling, a 5-gram sample of soil. And we take 3 of them per sample for volatile organic compounds by EPA method 5035. That's only true in that one area, jurisdictional area. If we go outside of that jurisdictional area, then we simply use a 2x6 steel tube, and then you take that to a lab. If you're going to use equipment for soil sampling, it absolutely should be decontaminated before you use it. You're using clean methods for your sampling, so you're using gloves, disposable gloves. You're doing it in a safe manner, absolutely safe. Documentation should be a must, and you guys should be part of that documentation as CUPA people, so that chain of custody is a standard document out here for if you're going to soil sample, if you're going to call it tank bottom north at 10 feet, then that should jive with what you saw on the site. It should jive with that sample on the documentation and the analytical results that you're going to get 3 weeks from now when you get a report of investigation. Analytical testing, as it goes with it, again, there's a bunch of regs and guidance document out there, whether it be the Luftmann, the tri-regional guidelines, or specific CUPA docs out there as far as analytical testing. Most tanks, I think in my experience, we know what they are, that we know what they had in them. Your probably biggest spectrum of testing for things is your waste oil tank, because waste oil tanks are typically a garbage can, so you could get anything from fuel, waste oil, solvents, brake cleaner, you get all kinds of stuff in there. But your standard fuel tank has a standard palette, and there's definitely guidance out there that I'm sure you're aware of. Sample preservation and ice chest, by the way, if you're going to take samples, you need to preserve them. EPA methods are out there for how that's done, typically 4 degrees C in an ice chest with real ice, by the way, not dummy ice. I've seen that before, so you know, the sample, again, if it's going to be representative, we're going to get that sample. Let's make sure we get it to the lab in a manner that is representative of what's actually there. Corrective action investigation, I mentioned this from the start because, again, once that sample's pulled, in my experience, you guys as CUPA oftentimes done. Your regulatory part of this thing's done. But again, objectives, what are you trying to do? If you're going to invoke corrective action on a site, then your regulatory authority oftentimes changes. You're then into a regional board or a local oversight agency that then has jurisdiction over the next steps and how you're going to do that. Again, in your site constraint analysis, you should have thought about all this stuff beforehand and set up to do it and done all your preparation. And when we're talking about corrective action, I'm talking about mass removal, impacted mass hydrocarbon, because that's typical. It could be solvent, by the way, it could be other things, but massive contaminant removal. We like to do groundwater pumping and removal. I think that there was some discussion earlier this week, from what I understand, a robust discussion about whether you do this kind of thing. I have found, by the way, if you have an open pit with free product on it, boy, that is a good time to get in there. But you better be planning to do that, how you're going to do it, what are you going to do with that water? We do groundwater treatment pump and disposal. We have a treatment trailer with 1,000 pounds of activated carbon on it. So we will treat that and we'll dispose it to the sanitary sewer under permit, and our local permitting agencies allow us to dispose of it to a wastewater treatment plant in the sanitary sewer. Disposal requirements then, they set the disposal requirements by the waste discharge requirements. Typically, if we're talking about soil, it's a mass removal through excavation and stockpiling. So this is a site that we did in downtown Santa Rosa, and I'm just going to kind of go through this because this is, and this is short, but this is a site. The bat phone rang. David, we're going to take out this gas station, and we're going to do this. So this is a site that ended up having 6 tanks on it. We found some surprises along the way, by the way. So before we did this, if you're going to do corrective action as a consultant, I want to know where my edges are. I do not want to dig on a site blind. I want to know where this thing, how deep, how far, and how wide, lateral, and vertical we're talking about. So we brought in a drill rig, and as engineers and consultants, that's what we do oftentimes to define the backside of a leaking tank. But in this instance, we did it before. So we brought in a hollow stem drill rig. We did a certain amount of site characterization pre-tank pull. And actually, you could see some white lines to your left side of the tank. That's actually delineating the tank. So we're pretty close to it in this drill rig. And at this point in time, this station was going through a decommissioning process, but we knew how deep and how far and how wide we were going to go through this endeavor. So then we brought John in, and John's really good at tearing these sites up. So John tears the station down, and he tore it all the way down. So there it is. The station's gone. We're ready to pull the tanks, and these are the tanks. So we send these tanks out. We get this done. Not a big deal. It's a big excavation, by the way. You oftentimes have tons or hundreds of tons of backfill from this type of thing. This site, by the way, was heavily contaminated. It was already in the cleanup fund. It already had regional board jurisdiction and oversight. So we set up and pre-approved the next steps. And the next steps on this site became one of the biggest digs I've ever done. We dug 11,000 tons of dirt out of this site. It was a huge dig. We also pumped groundwater. Behind that excavator, you could see what people commonly refer to as a Baker tank. So we were removing the mass out of groundwater at the same time. This is a big site, had a ton of stuff going on. Okay, so we get it, and that took many weeks, right? But the CUPA was a major part of that. CUPAs, by the way, in my experience, have jurisdiction oftentimes for removal of hazardous materials. So there is a permitting process for the removal of contaminated soil. But it's not their primary jurisdiction, and it's really not part of the tank pull. It's a second step and maybe a 3 or 4 step process. Okay, so we get this done. We go through, and I want to include some information just on site restoration, backfill. My experience, your materials that you're dealing with here oftentimes are prescriptive. A lot of your building departments really don't want you to use a recycled material. At least that's true in some of the jurisdictions in our area. So there's, as far as using, say, like a recycled base material is not allowed. So we're using virgin class 2 material. Oftentimes people want to reuse backfill or materials generated from the site. Region 2 Water Board has a very good, and actually EPA has a very good publication about sampling and how you do that. Typically, it's one sample for 20 cubic yards if you're going to reuse soil and reuse it as a reused soil. Again, I mentioned recycled materials. That's not a big deal. Compaction requirements. ASTM is a standard. ASTM 1557 is a standard guide for backfill and compaction. Structural requirements, again, this comes into our objective section because what are we trying to do here? We're trying to then, on this site, there was a plan to build a big building, like a 3 or 4 story commercial building. So we had enhanced structural requirements in our backfill. It wasn't 90%, it was 95%. They upgraded from a class 2 fill material to a select fill engineered material. So it's just a wobble in how we normally do it, but not a big deal. We plan to do that. And then, of course, you have a restoration of private property and the public utilities if you're going to be in that realm. So here we are, we're backfilling. We used, in this instance, you could see our shoring, our fencing. We got everything going on and what we talked about here. We're bridging groundwater here, by the way, with drain rock. Drain rock, in my experience, when you get into groundwater, can be a really nice tool. It gives you something solid to bridge on. Put geotech fabric when you get above waterways, and then start to do your compacted structural elements. So this turned into a great big dig, and my friend John's excavating. We took a bunch of material out of this thing. But what's really interesting is at the end of and here it is backfill, there's a bow mag in the hole. At this point, we're kind of rounding third and coming to home and getting done with this site. Here it is yesterday. I went out and took a picture of it yesterday. It's done. It's actually, we haven't built the building yet, but you know what, Woodstock's real happy because we took a whole lot of material out of this thing and it's a much better site. At the end of the day, by the way, your document as a CUPA agency that you should end up from this whole process of tank removal and documentation, disposal materials, and everything that's been done through this thing, we prepare a comprehensive report investigation. It includes the analytical results of those soil samples, that all that stuff jives on the chain of custody and process and procedure that took place on site. It includes the disposal documentation, not only for site-generated soil, but any water. It should include the tanks as well. So everything should be in one place. We're registered professional engineers and geologists, and it goes out of our office under their certification. By the way, if it's a leaking tank site and you have then the requirement to move forward from there with the leaking tank site, the unauthorized release statement through the process is a notification process to interested agencies. Then we have a leaking tank site, and oftentimes it's a pass off at that point from the CUPA to maybe a regional board or a local oversight program, or maybe even an LIA. So that is my experience in going through this tank pull process and some of the things to be considered. I thank you very much for having me here today. I know you guys are at the end of the last day of your CUPA conference. I believe Brenda's going to go next, and then we're going to take some questions at the end. So I thank you for your attendance.